Welcome to Qt FasTrack series for API 570 piping inspection code. In-service inspection, rating, repair, and alteration of piping systems.
In this lecture, we will continue discuss clauses 5, and we highlight important information contained items sub-clauses 5.12 Material Verification and Traceability, 5.13 Inspection of valves, 5.14 In-service inspection of welds, and 5.15 Inspection of flanged joints. Material verification and traceability. During repairs or alterations to alloy material piping systems, where the alloy material is required to maintain pressure containment, the inspector shall verify that the installation of new materials is consistent with the selected or specified construction materials. The owner-user shall assess the need for an extent of application of a material verification program, consistent with API 578 addressing inadvertent material substitution in existing alloy piping systems. The owner-user can make this assessment by 100% verification, PMI examination in certain critical situations, or by a percentage of the materials. PMI examination can be accomplished by the inspector or the examiner with the use of suitable methods as described in API 578. If a piping system component should fail because an incorrect material was inadvertently substituted for the proper piping material, the inspector shall consider the need for further verification of existing piping materials. Inspection of valves. Normally, thickness measurements are not routinely taken on valves in piping circuits, body of valve normally thicker than other piping. When valves are dismantled for servicing and repair, the shop should be attentive to any unusual corrosion patterns or thinning. If noted, this information should be reported to the inspector. Bodies of valves that are exposed to significant temperature cycling, for example, catalytic reforming unit regeneration and steam cleaning, should be examined periodically for thermal fatigue cracking. If gate valves are known to be or are suspected of being exposed to severe or unusual corrosion erosion, thickness readings should be conducted on the body between the seats, since this is an area of high turbulence and high stress. Control valves or other throttling valves, particularly in high-pressure drop and slurry services, can be susceptible to localized erosion of the body downstream of the orifice. If such metal loss is suspected, the valve should be removed from the line for internal inspection. The inside of the downstream mating flange and piping also should be inspected for local metal loss. When valve body and/or closure pressure tests are performed after servicing, they should be conducted in accordance with API 598, valve inspection and testing. In-service inspection of welds. Inspection for piping weld quality is normally accomplished as a part of the requirements for new construction, repairs, or alterations. However, welds are often inspected for corrosion as part of a radiographic profile inspection, or internal inspection, when preferential weld corrosion is noted. Additional welds in the same circuit or system should be examined for corrosion. Radiographic profile examinations of welds that have been in service may reveal a flaw in the weld. If crack-like imperfections are detected while the piping system is in operation, further inspection with weld quality radiography and/or UT should be used to assess the magnitude of the imperfection. Additionally, the inspector should make an effort to determine whether the crack-like imperfections are from original weld fabrication, or may be from an environmental cracking mechanism. Crack-like flaws and environmental cracking shall be assessed by an engineer in accordance with API 579-1, ASME-FFS1, and/or corrosion specialist. Preferential weld corrosion shall be assessed by the inspector. Inspection of flanged joints. Flanged joints should be examined for evidence of leakage, such as stains, deposits, or drips. Process leaks onto flange fasteners may result in corrosion or environmental cracking. This examination should include those flanges enclosed with flange or splash and spray guards. Flanged joints that have been clamped and pumped with sealant should be checked for leakage at the bolts. Fasteners subjected to such leakage may corrode or crack, for example, caustic cracking. If re-pumping is contemplated, affected fasteners should be renewed first. Accessible flange faces should be examined for distortion and to determine the condition of gasket seating surfaces. If flanges are excessively bent or distorted, their markings and thicknesses should be checked against engineering requirements before taking corrective action. Fasteners should be fully engaged. Any fastener failing to do so is considered acceptably engaged, if the lack of complete engagement is not more than one thread. Additional guidance on the inspection of flanged joints can be found in ASME PCC 1. Review questions. Question number 1. The extent of verification materials used for repairs or alterations shall be determined by the
answer is C.
Question number 2. Material verification programs can find in.
Answer is D.
Question number 3. Gate valves suspected of being exposed to corrosion, erosion should have thickness readings taken.
Answer is A.
Question number 4. When pressure testing of a gate valve is performed, it should be conducted in accordance with a PI document.
Answer is B.
Question number 5. Environmental cracking noted during an in-service examination of welds should be assessed by the
answer is D.
Question number 6. What course of action is called for when an inspector finds a flange joint that has been clamped and pumped with sealant?
Answer is C. This lecture is prepared by Samir Saad, and this is his profile.